Hello everybody and welcome to CS202 Online, day one of actual lecture material. I hope you guys are all here. Uh, but yeah, I see that, but I don't think they understand what they've done when they did that. What's wrong with my neck with the green screen? Okay, so welcome. Very excited that we finally have the first real day of class and we have it here on Twitch Live. And then if you're watching on Twitch, be aware that the video is being recorded on Twitch itself and also for YouTube. That's why I have the chat. Why is it the quality is kind of weird? But it's going to be uploaded on my YouTube channel so that people that are not watching live can watch it on their own time, and also if you would like to rewatch it. So my tip to you is that you're watching the YouTube version, is if you have a question on that, is to go and send me a message on Canvas, email, or a Discord message as well, and then I can help you out with that. If you're watching live, please go ahead and ask questions. Just know that your text is being recorded. The reason why I have the chat here is because people on YouTube can't see your questions otherwise. So with that said, if you don't want your name to be public, then I would recommend that you use an anonymous Twitch name. That way that your name is not publicly recorded if that's what you prefer. Okay? By the way, yes, the channel points, you can get extra credit with those, but only if you redeem them for the extra credit. So those of you that are using the imposter check, that means that you guys are basically just lost those points. Yeah. Okay. So how many people do we have here now? I can't see how many people we have in the chat. I'm assuming most of the class is going to be here. 24? Hello. So, okay. Well, I guess let's go ahead and get started, okay? So, how it usually is going to run is... Okay, there we go. I have an iPad with a pen, or pencil, whatever it's called. And I will go ahead and use this as sort of my own board to write things on. So, I'll be writing things there. I could have things already written there, but usually I typically write everything. So like, if I'm trying to show you some concepts or something, this will be the way for me to show it to you, just like if I had a board. But it's so much better to use this in a board because trying to record a board and camera is just not good quality wise. And so that's one of the things that we're going to do. The other one we're going to do is we have coding. This is actually kind of the nice thing about remote learning, is that I have the ability to be sitting here in front of my own computer that I know and I have set up to have a Visual Code IDE running. Well, it's not, I guess it's just a text editor really. And then I have a terminal ready to run the code, and I have the ability to create files and make them. And I'm going to be making this folder called CS202, which I will be numbering like this. And the whole goal of that is that maybe once in a while, like maybe once a month or more frequently than that possibly, I can go ahead and upload this file, this folder with all of the code that I've written so far, so that you guys can play around with it if you so deem to be. You can see on the Discord, I did that over the summer. I uploaded all of the examples. So those are actually all the ones that we did during class. So like as an example, I typically just, there's no special order. I just kind of make new folders every once in a while, so there's not like a million files in each folder. But as you can see, this was me coding them, all the stuff about classes, and then we did some examples. That's where it says ships. I think we were doing like inheritance. Oh, this one's inheritance because it's inherit. So the names are all over the place. But really, it's more like if you're watching the videos, you know which file is what. So like here, I just made two called hello and hello two. And so the code I write here, if you want to see it, that's what I'll upload that for. So that's going to be the other side of the class. So coding will be here, and then any concepts will be over in the iPad. Okay? So hopefully with that, we all can kind of get through this and understand the material well, just like if we were in person, right? Okay, so what we're going to do today is we are going to go briefly over CS 135, sort of C++. And by the way, this is a good moment to say, yeah, I tell you guys not to use your money on Twitch, because I don't think I even get anything from that. And even if I did, it's like unethical and weird. So don't send bits or subscribe, guys. It's not good. But I can't stop you. So yeah. But anyways, I did teach the class of the summer. So on my YouTube there is a playlist. Yes, I do know some people. I know some people that do the subscription with the Twitch Prime because it is free. So yes, I guess you're also free to do that. It's a free country. But is the audio staticky for anyone else? I don't know, but other people can say if it is, I suppose. I'll try to bring the microphone closer. I have like that right there. So I can go really close to it like that, but it's kind of weird. So, what is that? Oh, you guys did the John Cena thing? Oh my gosh. Okay. So, anyways, basically, see, that totally threw me off now. Oh yeah. So, I have the entire summer course version of this, which is like a compressed version in the playlist on YouTube. So, if you want to watch that, that can be a good sort of supporting information to the class, because this is obviously a little bit slower because we have the full semester, so it's good. It means we're more detailed and more time to do more examples. But at the same time, you know, if you want to just like reinforce the material, the compressed version might be good, like before a test or something too. So there's that as well, and I have the same for 135. So if you need more review than what we do today, then that is going to be what the playlist for 135 is going to be good for if you need to review that stuff, okay? So, since we do have a lot of people live, how about you guys tell me if there's anything specific from CS 135 that you would like me to review? Otherwise, I'll just pick some stuff, but how about that? Vector, that's a good one, okay. All right. For that, let's just code an example of vector. Pointers is actually something we're going to learn in 202, so we don't really need to review it. We'll actually spend like a long time on pointers. Functions, we can review functions. Yeah, in fact, I want to talk about function overloading today too. So that might actually kind of segue into that. Buckets is 202. The example of buckets is 202. You know, it's very abstract because like, yesterday, I did the 302 class, and I reviewed 202 material. So, like, that actually might be kind of useful because I in that video for yesterday's 302 class, I did go over vectors too. So, I'm going to go over it again now, but you can check that out too. So, okay, let's go with here. So I'll put it as a comment so I don't forget. So we're going to do vectors, functions, you guys said. Pointers we're not going to do because, again, that's the topic we're actually going to learn. So, we have like 2 weeks dedicated just to pointers, so you know that will definitely come. If they talk about it in 135, it was more of an introduction, so that's fine. Same with stack. Stack is something for 202. I mean, this is 202, right? I mean, yeah, it's 202. Okay. And then everything else, I guess, will structs. Maybe somebody said so. Structs we can kind of go over. However, the first topic that we're going to learn next week, which is classes, is very much like structs, so that will actually kind of nicely go into that, but I'll still try and throw in something with structs in there if I have time. Okay, so yes, and I'm willing to, you know, the class finishes at 2:15, but I'm willing to stay a little longer if you guys have more questions and things like that. Okay, so let me go ahead and code, or let me first of all introduce to you vectors again, especially if you don't know them at all. Okay, pass by reference and pass by value. Yeah, I'll make sure I'll put that here so I remember. Ref value. Okay, so get live. What is get live? I don't know what that is. Okay, using classes especially structs. Maybe we went over that in Dolly's class near the end. Well, that's because it's an introduction to this class. So next week, the topic of the week is going to be classes. So when we talk about classes, then they'll really talk about classes and structs. But by the way, the only difference in C++ between classes and structs is that by default, classes are private and structs are public. What that means, I'll go over next week. But that's the only difference, by the way. So yeah, just a little quick fact. I think maybe he meant getLine. That would actually make more sense. But maybe we can go over getLine. But okay, let me go ahead and introduce you again to vectors, okay? Since that was the first thing that people said. So, for and while loops. Okay, I'll throw that in as well. Maybe even a range for loop while we're at it. Okay, so arrays are cool. You're able to keep a bunch of the same data type, right? Arrays are what is known as a homogeneous data structure because they have to be the same data type. That's unlike, for example, something that could be in Python. A list, for example, is a heterogeneous data structure. This is how you type that, better than trying to pronounce it. So homogeneous and heterogeneous, like that. Okay. So homogeneous means same data type throughout the entire data structure, and then the other one, heterogeneous, means different data types in the same structure. Okay. Python allows you to do that with lists. C++ by default will not allow you. You can get around that with some nasty code, but it's not really meant to be. Okay. Why do you say C++ basics? I wonder if there's like a big delay in the chat, because I think I said it like a minute ago. But because at the end of the day, 135 is really, really basic. Of course, it doesn't feel like that when you take it, but you know, it's like now algebra feels very, very basic if you're in calculus, right? But when you get to like differential equations and partial differential equations and that kind of stuff, then calculus seems very, very basic. So it's kind of like that ever increasing difficulty where things now look easy that before were like insanely hard, right? You know, back when we were in like grade school, trying to maybe like learn the multiplication tables seemed very hard, and now it's like trivial, right? So yeah. How do you access them functions by reference and such? Yes, we will do that. I put that in there. Okay. Slight delay, but not really an issue. Okay. So, going back to vectors. So, arrays are homogeneous data structures. Okay. And so, you can keep as many items as you want as long as you have enough memory for it, but you have to give a fixed size, right? So, if you have an array of size 10, you can only keep 10 items on indices 0 through 9, right? Remember, because arrays start counting from 0 in computer science, C++. So, what if you wanted to put in 5 elements? Well, you could make an array of size 5, or you could keep the array of size 10, but then you can go ahead and maybe have another integer that keeps track of how big the array is. Let me go ahead and show you that. That way it's easier to see. So include. By the way, FYI, there's construction happening behind my house, road work. So yesterday, like literally the floor was vibrating, and they could hear like a bass throughout the whole class. I hope that doesn't happen today, but if it does, just bear with me. I highly doubt it'll take long, because paving doesn't take that long, you know. Maybe, and by long I mean like more than a week. So hopefully they finish over the weekend. They woke me up at like 7 a.m. yesterday with that. Today I slept pretty long, which means they probably weren't working, or they finished. So, okay. Let me go ahead and make an array, which we're gonna call R, size 10, okay? And then maybe I'm gonna call another integer called top at 0, okay? So I have this little array, and how I keep track of how full it is with the top. The number in the top represents the index of the next available spot in the array, okay? Which means that if I want to figure out how big the array is, I can just look at what the number is because of how the indexing works. So, you know, if I wanted to insert something into my array, let's go ahead and do that in a function. Yeah, let's do that in a function, because then you can review functions as well. So we're gonna call our function insert, okay? And our function requires the array that we're gonna insert at, which is an integer array. And then it requires the size of the array, because we need to know the size of the array always, which in this case is 10. And then finally, we need to know the top of the array. So like how full the array is so far, so that we can increase that. However, sorry, I want to sneeze. Okay, it passed. So, okay, it passed. Okay, so the top however, is something that we want to update the value here, right? So here's the thing. This is passed by reference versus passed by value, okay? So the size is something that we don't need to change, right? We are passing it into the function to know that what the size is, but it's sort of like a read-only variable. We don't need to change it, right? So we can just get a copy of it and it's fine. The array is a reference. Arrays are always passed by reference, so that means that we are getting the real array in there. However, the top, right now we're getting a copy. So here's the thing, so we get this and then we're like, okay, oh, I guess we need one more parameter, which is what we're gonna insert. So I guess like the value, okay? So, what we're gonna do is we get the array, we get the top of it, which is the next available spot, and in there we're gonna insert the value. And then we would go ahead and say top plus plus, which is basically top equals top plus 1. But here's the problem with this code. The problem with this code right now is that the top is passed by value. When you pass something by value, you are making a copy of it into the function, okay? So when I'm making my function call here, I'm gonna do something like insert R10, because it's the size, the top, which is whatever, the top, and then the value I wanna insert. So let's say I wanna insert a 42, okay? And yes, the answer is going to be to put in that, that beautiful ampersand sign. So right now, if I want to run this, it'll work, it'll insert something, but the top is going to still be 0 when I want it to be increased every time I insert something. Or when I remove something, I want it to be decreased, right? And so yes, I have to pass by reference, and the way you do that in C++ is you put an ampersand in front of the variable name, or next to after the data type, like that. Either one is okay. They mean the same thing. And so now I am passing, oh, well, not in front of value, my bad, in front of top, but yeah. You could do it in front of value too, but it's pointless. So now I am passing top by reference, which means that rather than passing a copy of the value of top, I am passing a reference to it. Now, what does that actually mean? We kind of have to talk about how pointers work for that to truly be understood on the practical level, like how it actually functions internally. For now, and in 135, we kind of hand wave that and say reference. But what a reference really means is something that you should be asking yourself. And that question will be answered when we talk about pointers. As the quick answer teaser of the pointer sort of theory there is that we are passing the address in memory where top lives. And that address allows us to actually access top, the real top, versus just getting a copy of the value of top. And by the way, technically speaking, we are still making a copy, but we're not making a copy of the value. We're making a copy of their address. So it's like somebody gives me their address on a piece of paper. So in short, as the name here happens to, imply, value is being passed by value, which is funny. And then top is being passed by reference. Whenever you see the ampersand, it means reference. Whenever you see no ampersand, it means value. Exception is the arrays. Arrays are always passed by reference. It's just kind of, again, you have to understand how pointers work for that. Does that make sense? I'm waiting in case there's a delay. What are we using mainly in 2.2 from 135? Almost everything? Pretty much, yes. I mean, all of the stuff you learn in 135 is so basic to the... So, no, I keep using the word. It's so fundamental. That's a good word. It's so fundamental to 202. Like, functions are just fundamental. Structs, classes will be fundamental, which are basically structs. Yeah, I know, basically. Variables are fundamental, you know. The only thing I would say, it's a lot easier to say what we won't use from 135. We probably won't use the IOM and IP stuff, like IOM and IP, you know, that library stuff. That is not very fundamental. That's just kind of formatting text, so barely used around. File streams are situational. We do use them. I think you even use them in the first assignment, but we may or may not use them. So int top isn't reset to 0 by its reference because we are accessing memory, not the value. So when you're accessing the memory, you're accessing whatever top currently has. So top does have 0 at the first time, but after you update it here, it's going to have 1 afterwards. The best way to see is you can see out top here. Let's run this, by the way. I didn't run it for you. I might have a bug somewhere, so let's run it and actually see this happen, and then maybe also see out R0 as well to see if the number. Oh gosh, come on. Why can't I type this symbol? There we go. G++, hello. Come on, .cpp. There we go. 1 and 42. So, yep, it worked fine. Let me just add another end line there. Cool. So, can you go over Fasteners briefly? I'll add that to the list of things to go over. Are vectors a 135 thing or a 202 thing? Because I think they're supposed to be 135. I was very adamant to people to make sure that they cover them in 135. But the question is if they covered it or not. Of course, it's subjective. So that's why I'm trying to go over them now. Okay, so going back to what we're trying to do. Basically, we have an array. And we sort of implemented the system of being able to have the array partially full and keep track of that with the top, right? However, this thing, when it gets full, when it gets beyond 10, it breaks down, right? We can't insert anything else ever again. Alternative, we'd have to make a new array and put more things in there. For that, we have to use dynamic memory allocation to make it on the fly, which we don't know yet. So really, at this point in time, in our CS knowledge at 135 coming into 202, you don't really have an alternative with an array to have something that you just keep inserting things and never run out of space. When we talk about linked list in 202, you'll see that that is another way of doing it. But now we can't. So that is why in 135, hopefully, and if not just now, vectors are going to come to the rescue. How do vectors come to the rescue? Vectors are a standard template library class, which you know what class is, don't worry. But they're basically another library, like F-streams and IOStream and IOManIP, IOManip, string library. Vectors are another one to include. So let's go ahead and start off by including that, like that. And FYI, vector only works in C++11, I think. Otherwise, if you compile without it, it's gonna yell at you, unless by default you're compiling in 11. So arrays are technically finite, with vectors will be infinite. That's kind of a very dangerous thing to say, right? Because there's no such thing as an infinity in like practicality, except for like the universe potentially, and you know, things get iffy with those words. Let's put it this way. A better way of saying that is arrays are a fixed size that cannot ever be changed. Vectors appear to not be a fixed size and can always be changed. But it actually turns out that vectors are implemented using arrays as well. It's just a bunch of behind the scenes code, or I like to call it magic, to allow you to keep inserting into array. How does that actually happen in practice? Again, we got to talk about dynamic memory allocation for that to be something that we can understand. But what is really happening is dynamic memory allocation allows you to make arrays on the fly. And what happens is it makes an array of a certain size. And as it starts getting full, the computer's like, okay, it's getting full. Let me make another array, copy things over to the new one, and then he can keep inserting and he never notices that happen. So this is sort of this behind the scenes going on action, but it's still an array actually. So it's not some magical, amazing data structure. It really is just a fancy array with a bunch of stuff hidden behind the scenes. Just like a string at the end of the day is just a bunch of cars put together in an array, null terminated, and you know, there's some cool functions you can do to them, but it's just a bunch of cars. And what are cars? Just a bunch of numbers. And what are numbers? Well, just a bunch of binary, right? And what is binary? Just electricity, right? So it all kind of boils down to some basic sort of form, but you know, this is like higher level form of like more things in the same place, okay? So I know it's a lot of hand waving, but we really can't get into the details of how vectors work until we talk about dynamic memory allocation, which is going to be about a month into the class, I think. I don't know, it's like the 5th lecture in the summer, but I think it's about a month in person. So it's just a function that creates a new array with a bigger limit. Yes, that's one of the things. But if you want to know like more about vectors, if you go on Geeks for Geeks vectors, you can see there's like 40 different functions that vectors have to do like 1,000 different things. So vectors are like arrays plus extra. like arrays plus. That could be a way of thinking of it. Like they're the DLC for arrays that you have to get the full experience, basically. Okay, so let's go ahead and make one of these vectors. That's kind of, yeah. We don't want to encourage anybody to do drugs and things like that. So, because yes, I was gonna say arrays on crack, but I'm like, no, that's kind of an offensive term, so probably not a good idea to use that. This right here in line 24 is a vector. Okay, so this vector right here looks weird to you right now, especially this part. What is this, you say? Like this less than greater than sign thing is supposed to be for something bigger and smaller, or something like includes. So what is this, you guys? Well, you'll find out in a couple of months, near the end of the semester, when we talk about templates. This is a templated class, actually. That's the proper name of it. However, we haven't talked about templates, so again, we are going to have to hand wave and say that what this is doing is you can make a vector of any data type. Okay, so just like you can make an array of integers, an array of doubles, and so on, you can do that with vectors too. But whereas in the syntax of C++, you're putting like int r here you're putting the data type inside here. Okay, it looks weird. I promise you we'll talk about this in detail when we talk about templates. You'll even get to do an assignment on templates. So you will learn about this. I guarantee you. I will force you to do it. However, now is not the time for that. Now we're just going to hand wave and say that this is how it's done. Okay, so it's kind of just the name of the game with programming, that until you learn everything, you always have to hand wave some stuff. Okay, so this has created a vector. Okay, now a vector, once you created it, you can treat it like it's a regular array. So if you wanted to print out the contents of the vector, like what's on the first index as a vector, I could do the same array index access operators, which are the fancy name for the square brackets, and then just put an index in there. So like I could do that. That's perfectly fine. I believe the equal sign is overloaded to even put things in that way, but probably not the best idea. So the better way to insert things into this vector is using a function. So how do we insert things into the vector? That's a question too. Well, there's a function called pushback. First of all, does everybody remember the dot in the terms of structs and how it works? It is called the class member operator. Class member operator, I think. Yeah, I think it's class member operator. Yeah. Sorry, it's kind of left my mind for a minute. Class member operator. Member access operator. That's what it is. Member access operator, not class member operator. Member access operator. There we go. So, it's sad. I literally did summer CS 202 a month ago. I just finished it last week. Well, a week before last week, technically, and I forgot. So, yeah, member access operator. So, the dot is called member access operator. Okay, that's the dot. Yes, I know. That's a big thing I'm scared and worried about, because I mean, I taught back-to-back classes before, but like there was a 1 month winter break or summer break in between. But having just taught 202 over the summer, I am very scared that I'll have like a deja vu moment or something, or I'll have a moment where I'll be like, oh yeah, we talked about this already, guys, and it was like the summer version. So definitely, if you ever see me make an assumption about something like, oh yeah, we talked about this already and we did it, let me know. But I'll do my best. I'm trying, especially with 302 happening at the same time and having done the review for 202 in that class. Yeah. So yes, definitely keep me in check. Okay, so let's go ahead and use the member access operator. And then when you do that, if you have an IDE, you can see all of the functions available to use for vectors. And by the way, this is why documentation is such a nice thing. I know in 135, they probably told you like document your code and you're like, oh, it sucks. More documentation than actual code, and you're complaining and crying. And yes, we all go through that phase at the beginning. But here is the good side of that. When other people do it for you, that's when it's great. When you do it for it's like one of those like, it's not that fun to help others, but it's really great to get help from others, like the whole point of helping others is because, you have to be a good person, right? So kind of like the same thing here with coding. Writing documentation is usually meant to help others rather than yourself. Although sometimes, and more often actually than that one would like to accept, documentation also helps you when you code something, go to sleep and wake up the next morning and you don't remember what you just wrote. So in this case, documentation is very nice because when you look at each of these functions, you can see it has the parameters, what each parameter does, and a function description, which are also the same things that I expect you to write in your own code. So that's very useful because, like, for example, let's look at pushback. Why is that the only one that doesn't have description? That's weird. Okay, let's not look at that one. Let's maybe look at capacity. Let's look at capacity. Returns the total number of elements that the vector can hold before needing to allocate more memory. So this is, again, a vector is just a fancy array that keeps getting resized. This tells us how long until we have to resize it again, but we don't have to do it. It's going to be done internally. However, there is a function that allows you to do it yourself if you so deem to want to do that. Let's look at another one. Erase. Let's look at erase. That sounds kind of cool. So parameter, so what this one does is it removes, as it says right there, brief, removes element at given position. So if you want to delete something from the array, normally with a regular array, it's a pain because you delete something and then there's a gap in there. What do? You like shift everything back, or like what happens then, right? With vectors, there's a function that will take care of all of that. You just tell it what to remove and it takes care of it for you. It's like, don't worry, I take care of it for you, So yes. Like the mafia, they'll take care of the problem. They'll erase the problem. So yes, okay. So it's in your benefit to kind of look through these and kind of learn them. Insert again can put something in any position that you want, and so that's one of the nice things about documentation. Okay, but we're gonna use the only one that for some reason is not documented, which is pushback. Okay. I don't know why it's not documented, but pushback is the most commonly used vector function, which is the one that you insert stuff into the vector. Okay, so v.pushback is going to allow you to pass in a parameter, and that parameter is going to be what you want to insert to the vector. So let's say that we want to insert to the vector the number 88. Okay, that's it. Bam, we just inserted 88 into our vector. Let's go ahead and insert something else into our vector. How about we insert 99, and then maybe 78, and then, I don't know, I'm just kind of pressing keys to replace numbers. Oh, failed. Oh yeah, good enough. Okay, so we got about 5 things in there. That's how you insert things into the vector. Okay, how can we print the contents of the vector? We can use a for loop for that. So this is going to be a nice usage of reviewing for loops. So how does a for loop work? A for loop is a count-based loop, whereas a while loop is a event-based loop. What that means is, in reality, is both loops can be used interchangeably, but sometimes one loop fits better for what you're trying to do. In this case, the for loop basically allows you to print something a certain amount of times that you define ahead of time, such as, when you're printing an array, you know how many times you need to loop through to get each element. A while loop is something useful, like when you're reading from a file and you need to stop reading when you reach the end of the file, or you're processing an unknown amount of information, but you still have a way of stopping it, okay? So that's the good thing about while loop. By the way, there's also the do while loop, which is like the while loop, but the only difference being that the do while loop guarantees that you will go through the code at least once, because the check is at the bottom of the loop, not at the top, as it is with the for and the while loop, okay? So just a bit of a review on that. Okay, so int I equals 0, I is less than the size, which in this case is 10. Oh, sorry, no, the size of the vector. So that has a vector. How do we get the size of the vector? Well, let's look at our functions. We have one that's called size. Returns the number of elements in the vectors. Bam. We just got our size. I think it's a function, so yeah. And then finally, the third part of the for loop. So let's look more closely at the for loop, I guess. So the for loop is made up of 3 main components, right? We have what is known as the init expression, or the initializing expression. Then we have the, what is this middle one called? the condition, I guess, checking the condition of the loop, the exit condition per se. And then the third part is the increment, which is the post loop expression, I suppose. Okay, there's probably better names of this. I have to kind of, let me pop open the CS 135 notes and tell you the technical names of this. What would be the technical name of these? Let's see. Here we go. Loop expression. So here, let me copy and paste this. This is so a for loop is a statement designed to simplify the writing of a count-controlled loop. Okay, and so what it says is the for loop's three parts is called the init statement, which again I believe it stands for initialization statement. Then we have the loop expression, which is the middle one, and then we have the update expression, which happens at the end of the for loop. Okay, and so what that means in practice is when you start a for loop, you need to have some sort of counter that goes through and counts how many times you need a loop. That's the first one here. You usually declare a variable and you set it to 0, but you can set it to whatever you want. If you're counting down, for example, you can also leave that blank and use a variable outside the loop, although not recommended. It kind of defeats the purpose of a for loop. This part is checked at the beginning of the loop after this initialization runs, which, by the way, this only runs one time, and that's when the loop starts for the first time ever, but it never gets run again. These two get run every time the loop goes around. This one gets run at the beginning. So like it's possible the loop may never enter, which is a good thing in case that the vector was empty. After the loop ends, before going back and checking the loop expression again, it's going to run the update expression. And that's important that it runs the update before the loop expression. Otherwise, we could be looping forever. So yes. Okay. So now, and then of course the statement is the body of the loop. So in this case, we want to go ahead and print out the vector. So as I told you before, it is just working like an array. I can just go ahead and use the same syntax as the array. I can say cout vi like that. And that is going to go ahead and print out the contents of that index in the vector. So it really treats it just like an array, which is very intuitive for people using vectors who are new to it, because they can just, once they make the vector, once they use this pushback function to insert things into the vector, they can deal with it just as if it was a regular array, with the added bonus of very easily inserting more things at the end, or using the insert function to insert in the middle. Okay, but typically you don't do that in this class. You only really need to worry about being able to insert at the end. So really, if it's all of this is just confusing and your mind is blown and whatnot, you just need to know this is how you declare a vector. This is how you insert stuff into the vector, and you can deal with it just like a regular array. Okay, so hopefully you're not just limit yourself to that. But I'm saying, you know, in the worst case scenario, at least you should know that much to be able to code like some of these assignments. And I do believe in the first assignment you have to use a vector, because there's an array that's supposed to be dynamic. The benefits of having an hour and 15-minute class is that you're not having a headache cramming so many things in. Yeah, true, because I'm not, you know, in the summer with the 2-hour classes, you're really just like throwing a lot of stuff in there. Although today's the one exception. I think having a long day is good because you can review a lot of stuff. Yes, in fact, I did not make the first assignment. What we did is I am 202 coordinator, so I'm coordinator of the 202 sections, and I went ahead and decided to use the same assignments and the same test. And so instead of all of us, or one of us making all of the assignments, we split the work between all the instructors to make the assignments. And so in this case, the person who did the first assignment is you know, one of the grad students, and then the second assignment is being done by one of the faculty. Either way, I think in the second assignment they accidentally said dynamic arrays when they meant to say vectors or something. So I think for the first assignment you just need to use vectors. So yes. Should B0 equal to 1 or B1? Huh? Not sure what you're asking. Rephrase that. When you're saying v0, that means you're accessing the first element of the vector and you're setting that value to 1. In the array, when I is equal to 0, arrays start from 0. So the first index of the array is always going to be at spot 0, which is a little bit counterintuitive to the way that we think, because we think of the first spot as a 0. The example that I give people in 135 is to think of it like the way the US or Americans think of floor system versus like the British way. We think of the first floor as the bottom floor, and then we think of the second floor as like going up the stairs one level, right? So like 1 and 2. In Europe, and like the British people, they think of the first floor as actually what will be the second floor for us, and then the bottom floor they don't call first, they just call it like the lobby, which we could think of as their 0 floor. So you could think of like programmers think of the British style where like 0 is the lobby and then the first floor is what we would consider the second floor. So that can kind of help you with the indexing. So that is why I have here I equals to 0 and saying that the base level is 0 indeed. So yes, I think even some elevators in Europe actually have a 0 for as an indication of the lobby. So it kind of confuses people. I mean, you gotta like stop and think like, wow, floor 0. That's just deep, you know, existentialist. But then when you become a CS person, you're like, oh yeah, okay, that makes sense. Can we please go over a vector that has struct as a data type? Sure. For C++, it's 0 for the first element. Yes, it is. Indeed, it is. Yes. So, by the way, Fortran, I think, and some other languages like MATLAB for sure. Fortran, I don't know, but MATLAB for sure, they start their arrays from 1, which just adds to the confusion of programming in general. But I think the consensus in general for most languages is starting at 0, and that is why we have this starting from 0 here. Okay, but before I start, let's just make sure that this works. By printing out all the numbers. Here we go. So we got all the numbers printed out in this in the order, yeah, because we got 88, 99, 78. Ignore the first 2 because they're coming from the top code. So yeah, it worked just fine. Okay, I'm glad you got it. I'm glad you got it. See, that's the one bad thing about like remote learning is that you guys are limited to typing your questions. So like, you know, it's harder to try to express yourself in just text. So, but hey, we're doing a good job so far. I was reading 142. Yeah. I see. Cool. Okay. So before I show you the struct one, let me go ahead and show you guys how to do this with the while loop. How about that? Why is the first one 1 here? This is coming from the top code over here because we see out top and we see out AR0 here. So if I put an end line, we can split that up. You see that? Now it's split. Yeah. Yep. You're right indeed. Yep. Okay, cool. So let me show you really fast before I show you the struct one on how to do the same code with the while loop as a quick refresher. So we would need to have the counter outside. So let's make an int I equals 0 while I is less than b dot size. And then at the bottom here, we need to do the I++. And then here, we just need to do the cout. In this case, how about we print it horizontally? So instead of putting each one per line, we can go ahead and put the end line down here. Oh, I'm sorry. I know you can't see that. And then let's add another end line. I'm going to put it here because we're starting to make the code big enough that it's kind of cutting it off, and I don't want that to happen. So I'm going to kind of squish the code together a little bit, okay? So I'm going to put all of these in the same line just because I want to be able to show most of the code. Otherwise, I have to keep scrolling back and forth, and it's kind of, it could be nauseating for some of you actually, like, yeah. So yeah, okay, there we go. So this is just the same loop. I mean, the same code, the same end result, different code, because one of them is using a while loop and one of them is using a for loop, and I suppose in one of them I'm doing it horizontally. That's just because I did not put an end line, but I put the little spaces here, okay? The last one I want to show you is a range-based for loop, okay? And this one may be new to you guys, and you don't have to use this at all, but I think it's something nice to know. So a range-based for loop is very cool with vectors because of how it works. You can do something like for int I, and then the name of the vector, and then C out VI. And by the way, if you're asking like, why am I printing the first time with 2 quotes and 1 quote, I'm doing that intentionally to show you different ways of doing the same thing. This one's using a string technically, this one's using a car. And this one I'm not putting the curly brackets to remind you that you don't need to if it's a single line of code inside of your loop. I will need to put that manually, otherwise it will yell at me. Okay. Why did that fail? Why did that fail? That's weird. Oh, I see why. My bad. I don't know what I was thinking. There we go. Yeah, okay. I know, right? There we go. Sorry. I was copying and pasting too far. Too much code without thinking what I was doing. So this is what is known as a range-based for loop. You may have not ever seen this before. Fear not. I'm going to try to walk you through it in the next 5 seconds. But if not, then it's okay. You don't ever have to use this. I just think it's useful to know. So a range-based for loop is something that kind of comes from like the Python people, and I am a Python people. I prefer Python over C++. But basically, in Python, you have something. You write a syntax that's saying like for A in X, and X is basically in some sort of list, and A is an iterator per se, because what it does, and it's happening here too when you say for I in V, is that V is your vector, and what's going to happen is this thing is going to loop for every element inside of V. So for each of the ones here, okay? And so what is happening is every time it iterates or loops, it's going to copy that index of V into I. And it's important that I say the word copy because it's like passing by value kind of copy. And when it's making that copy, then you can go ahead and print out and do whatever you want with it. However, if you're trying to modify it, it's kind of weird, but you have to put an ampersand here as if you were passing by reference, because you have the same problem you have with passing by value, passing by reference here. It's kind of the same thing here. Okay, so that's all I'm going to say about that. I did go over this in more detail in the 302 lecture yesterday, so you can check that out on YouTube if you want, or you can just Google for range-based for loops. I just kind of, since it's not something critical, I'd rather go to the ones that you actually have questions on that are more relevant. But it's just a nice little cool thing to know, okay? So we can talk about it at a different time. But now I want to move on to your other guys' questions, which was, for example, the struct. So how do you make a struct, a vector struct? Or a vector struct, yes, that's what we do right here. So let me go ahead and make a struct really fast. They're called range-based for loops. Sorry, English barrier for me to pronounce that correctly, but range-based for loops, like that, okay? Oh, let me move this out of the way. Okay, range-based for loops. And so, okay, let's build a struct. We're gonna call our struct, and by the way, I'm gonna give you the same warning that I gave my other class. I'm not very creative when it comes to variable names. I typically use A, B, C, X, Y, Z, I, J, K, but and mostly it's because it's not because I'm trying to make the code confusing. It's because I'm trying to code really fast as much as I can to show you as many examples. That's why I usually use all these like weird variable names, like single letters, because it's faster coding for the purpose of examples. But always make your variables meaningful names. You know, if I was turning it as an assignment, I'd get a bad grade because I would be like, what the? I mean, R is like the closest thing to a meaningful name. Actually, top is a good one. But other than that, like V is just a terrible name for a vector. So yeah. As I said, what I will do is I will try to post it occasionally. I do save a copy of everything, but since it's too much work to upload every single day, I will try to post it like every maybe like 2 weeks. I was doing it every week over the summer because we have 5 days, 4 days. Here I'll do it every 2 weeks. I'll just upload the latest version of it to Canvas and also make a copy on Discord or even maybe email spam you guys. I don't know. I'll figure something out. But yes, I will make a copy of it. For sure, I'll give you copies before tests and things like of that critical nature. So yes, and if there's a specific day where you really want to get that code immediately that day, I can always try and do that too. So yes, like if we have a specifically hard topic where you just really need the code to help you out. And again, this is available on YouTube as well, like the video. So you can always kind of copy a line from the video later on. So yes, okay. So we are 25 minutes left of class. Okay, cool. So let's make a struct that has just a variable in it, and that's it. So now let's go ahead and make a vector of these. Actually, you know what? Maybe we move on to another page so that we have more space. I think that might be better. Let's just copy this over here. And what do we have left? We did this. We pretty much kind of did this. We still need to do overloading. We probably won't get today. And we did the for loops. We already talked about that. So that's kind of where we're at. Okay? Yes, you do. I just hadn't gotten there yet. Yes. Okay. And the same with classes. By the way, I always forget that semicolon. So like I had it today because I actually was going to type it, but like legitimately I probably will forget it a lot of times this semester. So like, and then I'll see it and like low key. I mean, even yesterday I was writing a class and I forgot it. So definitely remind me about that. It's good. Okay. So if you want to make a vector of structs, all you gotta put in is the class or struct name. So in this case, it's A. Okay, and then you can go on your merry way. So let's go ahead and put a struct in there. So let's say we have a struct A called my A, and then my A.x. This is how you access the members of the struct, and maybe you set that to 40. And then let's make another one called other A, and then maybe that one we put in 20. Okay, and so if we want to insert either of those vectors, and let's do both actually, into the either of those structs into a vector, we can go ahead and use the pushback function for that, and then just put in the variable name of the struct. So like my A, or v.pushback other A. And there you go. Obviously, well, obviously to me, not to you guys probably, but it's important to understand that you cannot just see out a vector, right? Or sorry, a struct, or a vector too, actually. You can't just do this, see out my A. That does not make sense because the operator for see out, what is known as the stream insertion operator, that's the name, that's the official name of this guy. Whereas, by the way, for reading in, see in, that is the stream extraction operator. I always mix those up, but basically, what does I know easy way of calling it the see out operator or whatever. But the operator that will write to this terminal here, this is this only works with built-in data types. When you're trying to use it on a struct or a class, you have to do what's known as overloading to be able to get it working. We will talk about operator overloading, and we will do examples where we can actually get this going after doing some code. But by default, it will not work. Okay, so that will not work, and because of that, an array of vectors or an array of structs or a vector of structs, neither of them would work this way. Okay, but what we can do is we can print out the individual X. So let's go ahead and do that. So let me go ahead and put a for loop here. Let's use the range of for loop one more time, just the reviewer, how that would work with a vector. So let's go ahead and use that, and v. Oh, dog. This is my dog. Sometimes she comes and says hi, and then sits behind me for the class. I start sweating because it's hot. But yeah, okay. So we can do something like I.x and see out that. Okay? And so what is this going to do? This is going to iterate through this vector, and it is going to take each of those structs, and then I'm going to access the individual variable int x that is inside of each of those structs. So if my calculations are correct, you should see a 40 and a 20 print out. Oh, let me compile the right one because usage files. Oh, snap. There we go. I just needed to compile in 11. And there you go, 40, 20. What is that inside of the for loop? The auto and %I and v. So, I don't know, maybe it's possible that you guys didn't see the auto keyword being used. So what the auto keyword being used is, yeah, okay. So let me show you that real fast. Normally in C++, when you declare a variable, you got to give it a data type, right? You have to like int, int I or like double K or so on, right? And so auto is like shorthand for that. So auto allows you to not give it the data type. However, C++ requires the data type of each variable when it's being created. So it can't just work on its own. But if you're going to immediately insert something into the variable like this, so when you're doing a declaration and initialization in one line of code, the compiler can deduct that the data type of this is an integer. Whereas if I put something like hello, it can deduct that the K is actually a string. So it's like the lazy man's way of coding where you don't have to put in the data type. People don't really enjoy, or they don't enjoy, that's the word. They don't really like doing that because it's a little bit confusing per se. Yes, it is like bar in JavaScript, except yeah, sure, yeah, you can think of it that way. But remember though, in C++ you have to give in the data type, but you can let the compiler deduct it for you. So in this case, the reason why it's very popular to use an arranged for loop is for laziness, because I don't have to worry about the data type of v. How could I reword this to make it a little bit clearer perhaps? I can change the auto to the a, because that's actually the name of the struct, right? But auto is just I know it's like more writing in this case, but it just makes life easy, because sometimes the classes here have really weird long names and it's kind of complicated to know the exact data type, especially if it's a pointer and there's like up and down casting, which we'll talk about later on. Things get complicated, so it's just easier to just type in auto. It just makes your life easier. So that is why you see it there. But these two lines of code are equal. All that's happening is auto is being replaced by the A, and it's doing that. The compiler is doing that for us versus us doing it. So that's where the auto comes from, okay? So again, you don't have to use it. You might see it in some of my code because I do sometimes use it, but it's just a nice little feature. By the way, it's only in C++ 11 or later. So that's why I had an error when I tried to compile it in not C++ 11. So yeah, okay. So anyways, that is a struct inside a vector made up of structs. Okay. So file streams. Let's do file streams next. Are we allowed to use auto? Yes, you are. You are allowed to use auto. You are allowed to use vectors. So unless I specifically tell you not to, you can use that. It's good if you use it once in a while because you want to familiarize yourself with all of these different features that the language has. Remember, even after you take 202, 135, 302, and all these programming classes, 326, you're still going to know maybe like 20% of C++. I know maybe 40% of C++. But the language is insanely big that Very few people, even the guy who probably made C++ doesn't know it fully nowadays because it's been updated. So like, you know, it should always be a situation where you seek additional knowledge outside of what you're learning in school, because we don't have the time to go that hardcore. Really, you're only learning programming in UNLV because we want to be able to get onto something like data structures and then talking about other theory versus just coding. So it's more of like we have to do this to get to the cool stuff. So by no means is this an exhaustive or complete cover of the full language. So there's always going to be stuff to learn. And I strongly encourage you to have that motivation to seek this additional stuff on your own time, because that's the way that you're going to become a better programmer. Really? Who was your instructor for 135? I'm curious. I want to yell at them. Do attendance extra credits stack? They do, but only the one that says attendance. So like, making me dab will not give you extra credit. Brian Page. Well, I'll go yell at Brian Page later. Yes. I strongly disagree with him on that. And I have a PhD and he doesn't, so like, ooh, yes. Okay, I'll talk to him. He's a friend of mine, so I can make fun of him. It's okay. So yeah, all right. Okay, so we still got 15 minutes. I don't think we're gonna do the function overloading. I think we can. We might be able to. Let's try really fast going to file streams. Maybe I can even pull up a file stream. No, a file with file streams in it. No, it's just gonna be faster to type an example. Is function overloading important? Well, it's something that is useful to know. And I have it listed as one of the required. That's actually a required thing that I have to go over in this class that I told people to go over, so I have to go over it as well. So like that's actually something that we don't expect to be taught at 135. If it is, then it's great, but we don't expect to. So it's not like autos where I can just be like, oh yeah, no. This one's like one of those like has to be done kind of thing. Will you be uploading these examples anywhere, or is there? No, I will. Like I said, I will. It's just gonna be like maybe once every 2 weeks on Canvas and Discord. I'll make them both. I'll try to make them both available in those places. So you will have access to these in addition to it being on YouTube and being able to copy things. It's just I have to like, it's a multi-step process. I have to copy it from my VM to my machine and then to the internet. So I have to like move things. I use Dropbox for that. And yeah. Okay, but you will get them. Don't worry. Okay, so file streams, you need the fstream library for that. And let's go ahead and do an out stream first. So the one to write to a file. So what you want to do, and again, this is a very quick, dirty version of that. I have a video on this if you want to watch more in detail. But for that, you want to create an OFStream variable like that. And then just call it something, whatever you want. It's a variable. And then once you create a variable, you want to, this one, again, we're going to write to a file first, okay? Because that way I have a file to read from once I run it again. So yeah, we have OFStream variable, and then we need to open that file. We use the open function for that. It's part of a class of fout. And then you put in the name of the file there. So like, we're going to call it outtest.txt, okay? Just any file name. And now that you've done that, you can write to it just like if you're using cout. So you can write to it like hello world, CS202 online. And then when you're done, you can close the file. And that is how you do file streams in like less than a minute. Okay, let's just see if it worked. What did I screw up? If I'd open, oh, I forgot semicolons. What is wrong with this? Oh, shoot. I flipped these. I don't know why I flipped them. My apologies. It's supposed to be cout style. All right, that's what happens when you try to do things quickly. Okay, so we don't see anything happening here. However, if we type in ls, which remember if your Linux commands ls to show the screen, what's another good one? pwe to show the location of it, and so on. You can see here that we have an outtext file. So let's go ahead and look at that. Let's use the cat command for that, which shows you stuff in the file. Hello world, CS2 online. So there you go, the file worked. I just would prefer to have a line feed at the end of that. Come on, execute the file. And then see the file. There we go. Okay, so now it's in its own line. So you can see the file stream work. So now that it worked, let me go ahead and comment this out. And now, how about we read from the file? That's the other side of file streams, right? So for that one, we use an ifstream variable. We're going to call that fn. We're going to open the file again the same way. It's because this time you have to make sure that we put the same file name, otherwise we will get an error. So that is that file. And then now we're going to use this one, not the other one because I flipped them, and read in somewhere. So in this case, we are going to read into a string variable, str. And so let's just say str, and then let's echo it to the screen. Or here, let's read both of them in first and then echo them. So string str2, fn str2. I think that's going to read hello and world only. Yeah. So how about actually just do a for loop? Or a while loop. While fn str. Yeah, we'll do it like that. Okay. Cout str. Okay, so that should read everything. I don't think we'll have problems with it echoing the last thing or skipping the last thing, but we'll see. Compiles and runs. So okay, well let me just add some spaces to this. Okay, so let's kind of look at what we did because I kind of did type pretty fast there. So what I did is I went ahead and opened up I created an ifstream variable, which is part of the include fstream library class. And so then I use the same open function, which is the name. You got to put in the name of the ifstream you just created. So in my case, fn dot, which is the member access operator. Open, which is the function name to open a file, whether it's writing or reading, and then you put in the file name in quotes. If you want to use a string variable here, that's fine, but if you're not compiling in C++11, you are going to run into a problem with a segmentation fault, in which case that you can use the c.estr function. If you're into that problem, just contact me and we can go over more of that in detail. What is my what? Word per minute? For typing? Oh, I'm not a fast typer. I've seen students who type like 20 times faster than me. Like, it's scary. So, yeah. Especially the first time ever I was teaching 302, and I had a student who typed so fast that like I could not read as fast as he was typing. So like he typed faster than I could read, which is kind of scary. So it was intimidating for sure. I was like, what is he doing in this class? Like, he should be teaching it or something. But we got through it. I hope he got a positive thing out of the class. But yeah, that was cool. He was a really good programmer. I hope he graduated by now, and I hope he has a job. So yeah. So he flexed. So yeah. But anyways, going back to this. After you open the file, this is one sort of typical way to read from a file. You can use the reading command right here, the fnstr right here. You can use this to detect when you get to the end of the file. It's a nice little trick that you should know. And then you can just process whatever text you want in here. In this case, I'm just printing it out, but you could do something with the text. But this is very important, cool, and a nice thing to do here. The other way to do it is fin.eof for the end of file, but I prefer this method. And as you can see, it worked. It got rid of the, when it was in the file, it was written like this. It became like this because when you're reading in, when you're using the stream extraction operator, in that case, it removes all white space, which what that means is it removes all line feeds, all blank spaces, and that's it, I think. what's considered white space. And so because of that, we're only reading in the characters hello, world, CS209. That's why everything got read like squished together this way the first time around. Okay? So, yeah. That's file streams for you in very brief time. But again, the thing about file streams is not necessarily complicated as much as it is remembering. You know, a lot of people don't use file streams for a while, and it's natural. You forget the name of the library, you forget the name of the functions and all these things. But once you remember them, it's just really following the systematic system. Systematic method. I did forget one thing, by the way, to close the file, which I did when I was writing but not reading. So you can just close it like that. It's one of those things like clean up after you use a table kind of thing. You want to close files afterwards to be nice in this. What happens internally is you want to release some holds on the file so that other programs can use it potentially. So that's kind of what it does, which happens automatically if you don't release it by the time the program ends, right? So yeah. 4 minutes. No, we can't do function overloading in 4 minutes. Does anybody have other questions? We will have to do function overloading next time. Could we read the white spaces? Get line. That's right. You can use get line for that, or you can also use get car for reading in white space. So get line or get car. Get line is actually very, very, very useful function. Here, let's use get line to read in the 2 lines in one go here. That's actually kind of a good one. So we'll do that as the last example. So we're gonna say while dot, we'll use the end of file thing, and then oops, we have one too many of those. Get line, and then get line, you gotta put in the file stream first, and then the string where you're reading into, and then the character delimiter, which means when you want it to stop. By default, it's a line feed, but you could make it a space or you could make it a specific character. We're not going to use either, so we're just going to leave it alone. And so now, if I remember get line correctly, oh, fin, not f out, sorry. I don't know why I put f out. Oh, sorry. That happens. My apologies, guys. My apologies. Thank you for letting me know. So let me go over that again since I did it off screen. I comment out the other fin line so that we can do a different way of reading in, which is using get line, because you guys wanted to read the white spaces. And so in this case, we can't use the same line of code to read in and also check for end of file. We have to actually use the fin end of file function to know when to stop. And so that's why that is there. And now how we're going to read in is we're going to do get line fin str. The first parameter of get line is where you're reading from, which is usually cn, but it could be fn if it's a file stream. The second parameter of get line is going to be where to read to, which is usually some sort of string that you're storing the information on. The third parameter of that is optional, and it's a delimiter. It's called delimiter. What that means is by default, get line reads and stops at the line feed, but you can make it stop on any character that you want. That could be the way to stop the get line, such as a letter, a specific flag, a comma, whatever you want. So really, we're gonna stick to just leaving it as a line feed. But after we read it in, I'm gonna go ahead and see out it. Okay, so now it should read just twice and make it 2 lines. I guess it didn't read anything. Great. Why is it not reading anything? See out str. It's probably reaching in a file beforehand. Well, fn.e. Oh, well, not end of file. Sorry. We want to read when it gets to the end of file. So there we go. So hello world CS. Here, let me put an end line so you can see these here. And as you can see, it reads the hello world in its own and then the CS202 line, because now it is using the end line to split it. So that's how you use get line. Okay, so we got a couple of questions, I think. So the structs and function overloading next class. Well, no, I showed you structs already. What do you mean? I showed you how you do the little struct there. This Struct. But yes, we will talk about classes, which essentially is another review of Struct's next class. And function overloading will also be next class as well. Can we have a vector struct instead of str? Can we have a vector struct instead of str? Well, you could insert into a struct, but that struct is going to have a string field to be able to insert in there, right? Because otherwise this vector itself, I mean, you could make it a vector could be a string as well. You could do that. So like, you know, you could make a vector of string like that. And then you could read into that by putting vs here, push back. So like, if you want to make a copy of it, you could do something like vs does push back the string like such. You could do that. And then you could have a little for loop printing out what's in the vector afterwards. So as you can see, it printed out twice. So you could do something like that, but that's kind of the only thing I could think of in terms of that. So, okay, we are officially out of time. So I hope this was a bit of a useful review. Of course, again, you can't cover a full class in an hour and 15 minutes, you know, but there are resources out there. So and I am available to answer questions if you guys have any as you do the first assignment. I'm sorry, I'm a little bit tired from that, but welcome to the class again. I hope that you guys get a lot out of this class, and stay in touch over the weekend if you have any questions. All right, I will send out the poll to figure out how we're gonna do it with the lectures, because ideally it would be good if we could put them on like, I want to be able to have the YouTube video of the lecture uploaded by this time, which means ideally I want to have to try to record it on Mondays and Wednesdays, but the time we can move around there. So I'll put a Google poll out to see how you guys feel about that, and we'll go from there. Okay? So I hope you guys have a good weekend, but spend some time doing the assignment so you don't procrastinate it. So thank you guys for coming as well, and stay safe. You know, definitely stay safe out there. I believe it is, so that way you have a full week to do it. So we'll see how people feel about that. And if not, then we can mess around with the date. But ideally, we want to have a 1 week time period for each assignment. And if I delay this one, then that means you have less time for the next one. So we'll figure that out. I think it should be okay. Basically, as long as you have a good weekend to do it, then that's always like enough time, hopefully. So, all right then. Well, again, enjoy your weekend. I am available. So take care, everybody. When I was a student, did you suffer like all of us? I mean, I think we all suffer. I mean, like, I had a hard time in some of the math classes, and you know, I'm trying to think of what was hard for me. Programming was not hard. But like anybody else, I have run into situations where like code doesn't compile, or no, code segmentation faults. It crashes, and you're like trying to figure out for like 2 hours. I have had those situations happen, especially before I started using a debugger when I was like a student. Everybody runs through that kind of thing. Trying to use print statements is just not ideal. So, but yes, we all struggle with the topic. I mean, like, I have like a trauma of like taking French class and having a hard time learning that language. How much do you use higher math like calculus, etc.? Machine learning is like you use calculus a little bit, but it's mostly linear algebra that you use. That I think is more important than calculus for CS kind of machine learning stuff. But when you when you do neural networks, you have to take derivatives. So yeah. But I mean, it's like anything else. You struggle with content, and then you learn it, and then you struggle with the harder stuff, and it's just a ever increasing curve. I'm trying to remember the classes that I took. Because I finished my PhD from UNLV in 2019. I took classes in the spring semester of 2019. I'm trying to remember what I took. I took blockchain. I took a machine learning class. And I think I took something else, but I can't remember. And the blockchain class was hard. I struggled like anybody else. You know, I had to study, and I think the fact that I was getting older, it was harder to stay awake in class, which was a struggle. And it wasn't because the material was boring. In fact, I was super excited to learn blockchain stuff, but it just naturally sitting down in one place is just makes you sleepy as you get older. That was my biggest struggle. So there you go. That was my struggling to me, was actually staying awake in class. That is a struggle for me. Teaching, no problem, because you're moving, you're talking. You're like, it's impossible to fall asleep talking. I mean, no, it's probably possible, but like you have to be super, super tired. On the other hand, when you're just sitting back listening to the instructor, that is like super easy to fall asleep for me. And not because it was bad. And I always felt bad about that because I didn't want to give a negative impression to my professors that I was like, that they were boring, because they weren't. Which is why when I see people falling asleep in my class, I don't feel bad about that. So, yeah. My dog's name is Padme, and you will see her in a second when I end the video. But yes, this only happened to me as I got older. It did not happen when I was like in my early 20s. Like I was like laser vision. It only happened as I aged. So that's sad. But yes, my dog is sleeping here. Come on, wake up for a second. This is Padme, guys. And she just kind of keeps me company. Sometimes we'll bark and be toxic, but most of the time it's okay. And I wasn't even sleep deprived when that would happen, by the way. I mean, it didn't help, but sometimes I wasn't. It just happened. Like I could have slept 10 hours or 12 hours, and then I go to a class and be like, oh. But yeah, all-nighters are expected in CS lives. All right, guys. Well, I'm going to go and get all the stuff organized for the next class. So, all right, guys, take care and stay safe out there. And now you get to see my dog in the outro. See you guys.